Good morning, students. Yes, it's time for some questions to see for GW and Neet. Electric field. What is electric field? Yes, electric field is force acting per unit charge. Okay, E is equal to F upon Q. Electric field is vector quantity. Its direction is force acting on unit positive charge. Its direction is in direction of force acting on unit positive charge. Okay, due to positive charge, electric field is outside, and due to negative charge, it is inside. Yes, you have to write in short like this. Now we will see some questions. Now, yes, you know electric field due to point charge, due to system of point charges, due to electric dipole, due to shell, due to sphere, due to infinite long wire, etc., etc., etc. Okay, so yes, you have to remember equations of electric field due to various charge distribution. Now we will see some questions. See, charges plus 2q, q and q are placed at corners A, B and C of an equilateral triangle ABC. If E is electric field at circumcenter O of the triangle due to charge plus q, then magnitude and direction of resultant field at O is. You are given 4 options. Yes, first of all, see, we will draw one triangle. See, here it is. Okay, it is one equilateral triangle. Yes, it is. It is its circumcenter. Like it is A, B, here it is C. Okay, yes, we have 3 points. It is A, B and yes, it is C. Now, on A, charge is plus 2q. On A, charge is plus 2q. Here it is q and here it is q. You have to find what is force acting on this circumcenter. Yes, if E is electric field at circumcenter O due to charge plus q, then due to q charge it is force to E. Yes, these 3 are positive charges. These 3 are positive charges. Then due to these positive charges, first of all, you have to draw direction. See, due to this plus q charge at circumcenter, direction of electric field, it is on line joining 2 charges away. So it is E. Clear about this? For this charge, it is also positive, and due to q charge at center, what is direction of electric field? It is away, because due to positive charge, it is away. So yes, here it is. Any doubt? Okay, due to this plus q charge, in this direction. In this direction. Yes, here it is 2E. Here it is 2E. Why 2E? Because due to q charge, electric field is E. Then due to 2q charge, electric field is 2E. Electric field is 2E. Okay. Now what to do? Yes, now what to do? We have this electric field. It is E. It is E. And here it is 2E. And here it is 2E. Then how to find? Yes, how to find? See, here it is. Here it is. I will resolve this E into components. Yes, I will resolve this E into components. Okay, how to resolve? See, this E into components. One component in this direction, one component in this direction. Okay, to resolve this E into components, yes, we need angle. Equilateral triangle, so this angle 60. So obviously this angle will become 30. So yes, this angle will become 30. So it is E cos 30 and this component is E sin 30. Easy? Yes. Similarly, we have to resolve this E into components. One component in this direction and one component again in this direction. Okay, again this angle will be theta 30, so it is E cos 30 and here it will be E sin 30. Clear about this? Yes, we have to resolve these 2 vectors. Okay, now see, this E cos 30 and this E cos 30, they are of equal magnitude and opposite direction, so they will cancel out each other. They will cancel out each other. Yes or no? So at center O, in downward direction electric field is 2E, in upward direction electric field is 2E sin 30. Yes, in downward direction it is 2E, and in upward direction it is 2E sin 30. So it is 2E sin 30 means 1 by 2, 2 cut, so it is only E. So it is only E. So on this point, in downward direction electric field is 2E, and in upward direction electric field is E. So resultant electric field, it is in downward direction, and it is only E, and it is only E. So yes, on this point O, resultant electric field is in downward direction E. So yes, E, 2E, E and E, but along in this direction means it is along AO. It is along AO. So yes, your right answer is this, electric field along AO. Clear about this? So yes, this question you have to solve from this figure. Okay. Now we will see another question. See what is next question. 2 point charges plus 8Q and minus Q are located. Yes, 2 point charges plus 8Q and minus 2Q are located at x is equal to 0 and x is equal to f respectively. The location of a point on x-axis is at which the net electric field due to these 2 point charges is 0. See, yes, it is one question. You can solve this question directly. But yes, for such questions, when we want to find where at which point total electric field is 0, we have to remember such points. Okay, when you are given 2 light charges, for example Q1, Q2, they are light charges. Distance between them, it is R. So for 2 light charges, a point where net electric field is 0, it is somewhere on a line joining 2 charges, between 2 charges. On line joining 2 charges. Yes, it is line joining 2 charges and between 2 charges. Not at center exactly. If Q1 and Q2 they have same magnitude, then yes, resultant electric field is 0 at center. But in another cases, I am assuming, for example, let at this point, that is point N, electric field is 0 at distance x. So from Q2, what is its distance? It is R minus x. Now electric field is vector quantity and it becomes 0 when yes, electric fields, 2 electric fields, they are of equal magnitude and opposite direction. Yes, as it is positive charge, at this point electric field due to it E1 away. Q2 is also positive charge, electric field due to it is also away. So yes, direction is opposite. Now if their magnitudes are equal, then and then at this point electric field will become 0. So magnitudes become same means how to write? At this point total electric field 0, it means direction opposite, and magnitude means 1 upon 4 pi epsilon 0 Q1 upon x square, because point N is a distance x from Q1 is equal to 1 upon 4 pi epsilon 0, it is Q2 upon R minus x whole square. So 1 upon 4 pi epsilon 0 cut, 1 upon 4 pi epsilon 0 cut. So I can say Q1 upon Q2 is equal to Q1 upon Q2, or if you make subject like this, the R minus x whole square upon x square is equal to, it is Q2 upon Q1. So therefore R minus x upon x is equal to, it is Q2 upon Q1 its square. Simple. So therefore it is R upon x minus 1, it is under root Q2 upon Q1. Simple. So yes, therefore R upon x is equal to 1 plus, or you can say under root Q2 upon Q1 plus 1. So how to find x? Yes, x is equal to, it is R upon under root Q2 upon Q1 plus 1. Under root Q2 upon Q1 plus 1. Simple. Again, At this point, electric field is 0. Direction opposite, their magnitudes same. 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0. R minus x square this side in numerator, Q1 this side. Take square root on both sides. R upon x, R upon x. X upon x is 1. So R upon x is equal to Q2 upon Q1 plus 1. Q2 upon Q1 plus 1. If two charges are equal, means their magnitude is same, then see Q2 upon Q1. Q1 and Q2 same, then Q2 upon Q1 1. 1 plus 1 2. It is R by 2. Exactly like midpoint. So yes, this equation you have to remember. But yes, this equation you have to remember. And this distance x is from Q1. This distance x is from this Q1. This Q1. Clear about this? Now when you are given two unlike charges, whenever you are given two unlike charges, okay, if you are given it is Q1, it is Q2. Okay, for example, let this Q1 is positive and this Q2 is negative, for example. Okay, and we are taking also one condition, that is mode of Q1 is greater than mode of Q2. Means magnitude of Q1 is greater than magnitude of Q2. Magnitude of Q1 is greater than magnitude of Q2. Okay, then how to find? See, whenever, yes, 2 points, 2 charges, they are unlike charges. So obviously, between two charges, it is not possible that electric field will become 0. At each and every point, electric field due to Q1 and Q2, they will be in same direction. So there are no chances that between two charges, electric field is 0. So yes, another two probabilities on sides of positive charge and side of negative charge. But here, if Q1 is greater than Q2, mode of Q1 is greater than mode of Q2, then at this side again, effect of Q1 is more because its magnitude is more and distance is less. So yes, effect of Q1 is more and effect of Q2 is less. So again, at this point, no chance electric field becomes 0. So yes, you have to remember, when you are given two unlike charges, then electric field is 0. Electric field is 0 on side having charge having small magnitude. Q1 and Q2, yes, you are given two charges. Q1 and Q2, yes, you are given two charges. So at which point electric field may be 0 on side of charge having small magnitude. Yes, Q2, its magnitude is smaller. Then yes, null point is possible here. Null point is possible here. Let from Q1, again, its distance is x. So from Q2, its distance is x minus r. X minus r. Clear about this? So yes, how to write now this? Again, due to this positive charge, see, direction is outside, and for this negative charge, direction is inward. They are in opposite direction, and now if their magnitude becomes same, that is 1 upon 4 pi epsilon 0 Q1 upon x square is equal to 1 upon 4 pi epsilon 0 Q2 upon x minus r whole square. So 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0, x minus r upon x is equal to under root Q2 upon Q1. So therefore 1 minus r upon x, it is under root Q2 upon Q1. So therefore r upon x is equal to 1 minus under root Q2 upon Q1. And yes, therefore x is equal to is r upon 1 minus under root Q2 upon Q1. Simple. So yes, this equation you have to remember. Again, this distance x is from Q1. X is from Q1. Simple. Now for this question, the 2 point charges plus 8q and minus 2q are located at x is equal to 0 and x is equal to L. It is x-axis. It is x is equal to 0 plus 8q. Okay, another is located at x is equal to L minus 2q. Here it is x is equal to L. It is minus 2q. Then on the x-axis, at which point the net electric field due to these 2 point charges is 0. Yes, we are given 2 charges, and these 2 charges are unlike charges. These two charges are unlike charges. So for unlike charges, you have to use this equation. And yes, you have to find from plus 8q, and this plus 8q it is placed at x is equal to 0. So yes, for us it is q1 and it is q2. Then what is equation? What is equation? This equation is, okay, x is equal to L, R means distance between two charges. Here what is distance between two charges? It is L, divided by 1 minus under root q2 upon q1. Under root minus under root q2 upon q1. Under root q2 upon q1 means q2, it is 2q, and q1 means it is 8q. 2 cut. So is equal to, it is L, 1 minus under root 2 by 8 means it is 1 by 4, and 1 by 4 means it is 1 by 2. So x is equal to, it is 1 upon 1 minus 1 by 2. So it is 1 upon 1 by 2, and it is 2. Yes, here it is 2, means it is 2L. So at distance 2L, from 8q, resultant electric field is 0. So see, if you remember these two equations, you can solve questions in short time. Clear about this? Right now. Now next question for you. Two equal charges are separated by distance d. A third charge placed on a perpendicular bisector at x distance will experience a maximum force when x is equal to 80 degree. Okay, see what is question here. You are given two charges, q and q, separated by a distance d. So it is distance d. Two equal charges are separated by distance d. A third charge placed on perpendicular bisector. Yes, it is perpendicular bisector at distance x. From at distance will experience a maximum force. Yes, here also you have to place the same charge, that is q. That is okay. So see, distance of this charge from this point is this. This distance is d by 2. This distance is also d by 2. So what is this distance? Yes, this distance is x square plus b square by 4. Okay, this distance is also x square plus b square by 4. Simple? Yes. So see, these two charges are of equal magnitude. Distance same. So at this point, due to this charge and due to this charge, the forces will have same magnitude. Now about direction. See how to draw direction. Here it is. Due to this charge, forces acting in this direction, F. Yes or no? Due to this charge, forces acting in this direction. Clear about this? Okay, now I will resolve these forces in two components. See how to resolve these forces. First of this force, first component in this direction, second in this direction. Okay, yes, to find component we need angle. I am assuming this angle is theta. So obviously this angle will become theta. So it is F cos theta and it is F sin theta. Simple? Yes or no? Yes, it is. Okay, if we resolve this vector into components, first in this direction and second will be in this direction. Again, this angle is theta, so obviously this angle will become theta. So it is F cos theta, it will become F sin theta. F sin theta, opposite direction, equal magnitude, they will cancel out each other. So at this point, resultant force is force is F dash is equal to, it is 2F cos theta is equal to 2. F is force. F is force acting on this charge due to this charge, as well as F is force on this due to this. Yes or no? And how to find magnitude of force? F is equal to 1 upon 4 pi epsilon 0. It is 1 upon 4 pi epsilon 0. Q. Charge on this is Q. Charge on this, it is also Q. Distance. What is distance between these two charges? Under root x square plus d square by 4. And yes, here it is. How to write? Under root x square plus d square by 4 is whole square. Cos theta, yes, you can also write from figure what is cos theta. Cos theta means it is, yes, it is adjacent side upon hypotenuse. So it is x upon, it is under root x square plus d square by 4. Simple? So yes, is equal to, it is 2, it is, so 1 upon 2 pi epsilon 0 q square upon x square plus d square by 4, because square root and square cancel out. Okay, x divided by, it is under root x square plus d square by 4. Any doubt? Now I can write this term as f dash. So f dash is equal to, here it is 1 upon 2 pi epsilon 0 q square x divided by x square plus d square raised to power 1, and it is raised to power 1 by 2. So I can write it as x square plus d square by 4 raised to power 3 by 2. Raised to power 3 by 2. Any doubt? So again, f dash is equal to 1 upon 2 pi epsilon 0 q square x, and I can write this term as x square plus d square by 4 raised to minus 3 by 2. Okay, now you are given, okay, you have to find what is distance where force is maximum, where force is maximum. See, for maximum force on which it depends, its differentiation will become 0. Here force is function of x, because see, here 1 upon 2 pi epsilon 0 constant, q constant, d constant, only x is variable. What is your question? At which point, at which distance force is 0, that we have to find. Okay, so for maximum force df upon dx is equal to 0, because this force depends on x. Yes, it is one concept of mass. Okay, if for maximum force or minimum force, differentiation with respect to which, on which it depends, it will be 0. Clear about this? And if you derivate this equation second time, you will get minus sign, because if you get second derivation minus, force will be maximum. Okay, so yes, here it is df upon dx is equal to 0. Now df upon dx is equal to 0. So yes, sorry, df dash to resultant force. So d upon dx. What is f dash? Here it is 1 upon 2 pi epsilon 0 q square x. Here it is x square plus d square by 4 raised to minus 3 by 2 is equal to 0. Now 1 upon 2 pi epsilon 0 q square is constant, so out of differentiation, and yes, we will have only this term, that is d upon dx of x square plus d square by 4 raised to minus 3 by 2 is equal to 0. Clear about this? Clear about this? Okay, now differentiation is with respect to x, and we have two terms having x, and we have two terms having x. Yes or no? So what is rule? First term as it is, differentiation of second term, plus differentiation of first term, second term as it is. So yes, first term as it is x. What is differentiation of second term? That is minus 3 by 2 x square plus d square by 4 raised to minus 3 by 2 minus 1. Simple. And again, differentiation of this whole term means it is 2x. Okay? Okay. Then between there is positive sign. Between there is positive sign, because between there is plus. Now differentiation of first term, that is 1, and second term as it is, means it is x square plus d square by 4 raised to minus 3 by 2 is equal to 0. Clear? So see, this 2 cut, Okay, here this term, how can I write? It is minus 3x into x, it is x square. I can write this term as x square plus b square by 4 raised to minus 3 by 2. X square plus b square by 4 raised to minus 1, and plus this term, that is plus x square plus b square by 4. Or if you write this term on negative side, then minus x square plus b square by 4 is to minus 3 by. So see, this term and this term cancel out, and it remains minus 3x square upon x square plus b square by 4, because it is minus 1 power. So if we take in denominator, it will become positive, and this side here is minus 1. So this minus 1 cancel out. Okay, so yes, it is 3x square is equal to x square plus b square by 4. So it is 2x square is equal to b square by 4. Clear about this? Okay, clear about this? So yes, x square is equal to 8 is b square. This 2, it is here, so it is b square by 8. So what is x? Yes, x is equal to this plus or minus b. 8 means it is 2. 8 means it is 2. Clear about this? So yes, it is one whole question. It is one whole question. Yes, there are too many steps. There are too many steps, but as I have to explain you, I have to write these too many steps. Otherwise, I can also write directly. Okay, from this figure, I can directly write this equation. Clear about this? So yes, as I have to explain, I have to write numbers of terms, but you can also write this question, or you can also solve this question in shorthand. Clear about this? Write down. Now one extra point, one last point for today. See, if you are given a square means one regular object. Okay, 4 identical charges are placed at corners. Then what is electric field at center? Obviously, electric field at center EO is equal to 0. Why? These 4 charges are identical. Distance center to corner also identical. So obviously, if you are given a square and on all corners if identical charges are placed, then at center electric field is 0. And it is true for any polygon, any regular polygon. For regular polygon at center, E0 is equal to 0 if all charges are identical. Okay, but if I have one question like this, Q, and Q, and see, yes, such question we have already solved in NCERT textbook. One example, that for equilateral triangle, what is force acting on center? It is 0. Yes, force acting on center, it is 0. So yes, here at center electric field is 0. Okay, but if you are given a square means 4 corners, but only on 3 corner charges are placed. Then what is resultant electric field? If center to corner distances are, see, due to this, what is electric field? In this direction. Due to this, in this direction. Due to this, in this direction. Yes or no? So obviously, these two will cancel out each other. So at this point, electric field is due to only one charge. So yes, at center electric field, EO is equal to 1 upon 4 pi epsilon 0. It is Q upon R square. EO is 1 upon 4 pi epsilon 0, Q upon R square. So if you are given a polygon of n sides and charges are placed on n minus 1 corner, then what is electric field at center? See here. If you are given polygon of n side means n corners, okay, but charges are placed on n minus 1 corner. Charges means identical charges. Identical charges are placed on n minus 1 corner, that at center, and if center to corner distance is r, okay, then what is electric field at center? EO is it is only due to one charge. It is only due to one charge, that is EO is equal to 1 upon 4 pi epsilon 0 Q upon r square. Clear about this? So yes, you have to remember this one. But if all charges are identical, now you have to solve one question. If you are given figure like this, plus Q charge, minus Q charge, and minus Q charge, then if this distance is r, what is electric field at center? What is electric field at center, and in which direction? That you have to solve. Clear? So yes, for today this is it.